All right, talk about slope of a curve in polar form. The ones that we shall look at are the ones like where we have r equals 2 cosine theta, r equals 1 minus 5 sine theta. Those are the ones that, that we're going to talk about the slopes of. And so, in general, what we call that is r equals f, some f of theta, right? The r is given in terms of theta. That's the ones that we will do the slopes of. All right? Turns out, what we're going to do is we're going to write this in sort of a parametric form. Because here's what we know. In polar form, we've got the x and the y coordinate, right? We've got x is, it's kind of a combination parametric Cartesian form, if you will. Not really, but that's sort of what we're doing. Yeah, in Cartesian, x is equal to r cosine theta, and y is equal to r sine theta, right? Well, if that's the case, then, since we know r in terms of theta right here, we can make our substitution, whatever the f of theta is, whether it be 2 cosine theta, 1 minus 5 sine theta, we can say x equals f theta times the cosine of theta, and then y is equal to f theta times the sine of theta. And how does that help me? Well, that helps me because I now know that dy dx, my slope, still dy dx, right? The dy dx then, guess how I'm going to do my derivative? Well, I would do the derivative of the y over the derivative of the x. Okay? So what it will be then is I'd take, the derivative of this, f of theta times sine of theta, do the d theta of that, and then the d theta of the x, which is going to be the derivative of the f theta sine theta over the derivative of the f theta cosine theta. See what I'm saying there? Which, how am I going to do the derivative of f theta sine? Well, it's going to be a product rule. So the actual derivative here, I'm going to do the f of theta times the derivative of sine, which would be cosine, plus the sine times the derivative of f of theta. Whatever case may be, that we're doing. And then down here, same thing, but it'll be f of theta times negative sine theta cosine times f prime. Okay. Now, so officially, the dy dx, the slope, is this right here. Now, you can memorize that if you want to, or you can just remember that x is r cosine theta and the r is f of theta. And then you can just do the derivatives of those. Make that's the way I usually do it, is I make that substitution, and then I say, well, I do the derivative of that over the derivative of that. I don't try to memorize that. That would be tough, for me anyway. Okay? For example, is this all right? So dy dx for a polar curve is this, but let's don't memorize this. Let's just remember that we change it to x and y equations and then do the derivative off of that. All right, so let's find dy dx for r equals 1 plus sine theta. Well, to find the dy dx, so just note this. Find dy dx for a polar curve write it in terms of x in a parametric form. X equals r cosine theta, y equals r sine theta. Where I'm going to make this be my r. Okay, that's, and then do the derivative off of that. Okay, so in this case I've got x equals 1 plus sine theta cosine theta, and y is equal to 1 plus sine theta sine theta. Okay? So what is dy dx? Well, dy dx, I would take this, the derivative of the y one, okay? So I do the derivative of the 1 plus sine theta sine theta. And I guess sometimes you might be able to simplify if there's, a much simpler form of that. Go ahead and multiply that out, but I don't think multiplying it out would really save us anything, so just do the product rule on this. Product rule, derivative, so I do 1 plus sine of theta times the derivative of sine of theta, which would be cosine theta, plus the sine of theta times the derivative of 1 plus sine theta, which is cosine theta. So all that's the derivative of the y equation. And then the bottom we're going to do the derivative of the x equation. So that would be 1 plus sine theta times the derivative of cosine, which is minus sine, plus the cosine times the derivative of the sine. 1 plus sine, which is cosine. Now, at this point, we probably can, looking at it here, if I distribute my cosine, that would be cosine theta plus cosine theta times sine theta. And then we've also got a sine theta cosine theta on top there. And then here I have minus sine theta times minus sine squared. Theta, right? If I distribute the sine, minus the sine, plus cosine squared. And so to clean it up a bit, then I've got like terms here, don't I? Sine theta, cosine, or cosine, sine, same thing as sine, cosine. So I've got one of those, and so I've got two of those. So cosine theta plus 2 cosine theta, sine theta, or vice versa, I guess. Anything on the bottom? Yeah, if it was plus sine squared plus cosine squared, that would be 1. Actually, well, I think it's, cosine squared. I think that's a double angle, but we won't worry about that. If it was 1, I would change it, but we'll just leave it like that. Okay? All right. Let's try another. Get the hang of it here. Okay, find the slope of the curve. R equals 2 cosine 2 theta at pi over 6. All right. right, so there's not just a nice way of doing it other than to say, well, R, I can write this parametrically, if you will, as doing x equals R cosine, y is R sine. So in this case, it would be x is, that goes in for R, right? Cosine 2 theta times cosine theta. Y is, R is cosine 2 theta, so it would be cosine 2 theta times sine theta. And so the slope, the dy dx, is, well, it's in the derivative of the y, which by product rule would be cosine of 2 theta, times the derivative of the sine would be cosine, plus the sine theta times the derivative of cosine of 2 theta, which would be minus sine of 2 theta, but there's a chain rule because I've got 2 theta. I have to multiply that by 2. Then the bottom is going to be the derivative of the x equation, so that would be cosine 2 theta, times the derivative of cosine, which would be minus the sine of theta, plus the cosine of theta, times the derivative of cosine of 2 theta, which is negative sine 2 theta times 2. Not much you can clean up there, I don't think. It's cosine 2 theta times cosine theta. I can't combine those. Minus 2 sine theta sine 2 theta. About the best I can do there. That would be minus cosine 2 theta sine theta. And then minus 2 cosine sine 2 theta. So that's my dy dx. And so in this case, I want the specific one where theta is pi over 6. So that would just mean plug in theta to be pi over 6. So my slope is going to be dy dx. What would be cosine of 2 times pi over 6, that's going to be pi over 3, times the cosine of pi over 6. So you have to remember some trig angles here. Minus 2 times sine of pi over 6 times the sine of 2 times pi over 6, which again is pi over 3. And then on the bottom I have something similar. Be cosine of 2 theta is going to be pi over 3 minus, it is, times the sine of pi over 6 minus 2 times the cosine of pi over 6 sine of 2 theta, that's the pi over 3. Okay. So if we can remember our cosines of pi over 3's and pi over 6's, we'll be all right. What's the cosine of pi over 3? That's 60. Be a half, wouldn't it? Cosine of pi over 3 is a half. Cosine of pi over 6, square root of 3 over 2. Minus 2 sine of pi over 6, well, sine of 0 is 0, so sine of pi over 6 is 1/2. That's the way I remembered it anyway. Sine of pi over 3 is square root of 3 over 2. So yeah, we're getting a lot of halves and square roots of 3 over 2. Minus cosine of pi over 3, well, that's 1/2. Sine of pi over 6 is also a half. Minus 2 cosine of pi over 6, that's square root of 3 over 2. Sine of pi over 3, square root of 3 over 2 also. So we have square root of 3 over 4. 2's cancel, so it's minus square root of 3 over 2. That's minus a fourth. And let's see, those 2's cancel, so it's just, that would just be 3/2. What do you want to do with that? Well, we can combine these as one. That would be, what, square root of 3 over 4 minus 2 square roots of 3 over 4. And that would be minus 1/4 minus 6 over 4, wouldn't it? which would be negative 1 square root of 3 over 4 over negative 7 over 4. What happens? 4's cancel. So we have negative, so it'll be positive square root of 3 over 7. That's what I thought it was, right?